Subatomic particles are the building blocks of an atom. There are three main subatomic particles. These are protons, neutrons, and electrons. I'll go ahead and discuss each of them. So, the first one is protons. Protons are positively charged particles. They are one of the two particles that make up the nucleus, the other one being neutrons. So, as you can see here, this is our nucleus, right in that center. And you see here that we have these positively charged particles. Those are our protons. The green part, those are the neutrons. It's also located in the nucleus. The number of protons in an atom is based on the atomic number. So the atomic number is located right here in an element. However, when you look at a periodic table, it's actually the number that's right on the top. So in a periodic table, it would look like this. This would actually be the atomic number. Now, let's give an example. So according to the periodic table, hydrogen has one proton. Why is that? Because the atomic number in the periodic table is 1. Carbon has 6 protons because its atomic number is 6. And oxygen has 8 protons because its atomic number is 8. Meanwhile, neutrons are neutral particles. They have no charge. This means that their charge is 0. They are about the same mass as protons, but they have no electrical charge. Neutrons, along with protons, make up the atom's nucleus. As I've stated over here, this is where the nucleus is at. The green part is the neutron, the orange part is the proton. As you can see, there's no indication of any positive or negative, and that's because neutrons are neutral. They don't have a charge. But the question is, how are they calculated? The number of neutrons is determined by the mass number of an atom. So what you do to calculate the neutron is you subtract the mass number and the atomic number. So let's go ahead and look at an example. The example we have here first is carbon with a mass number of 12. Since the mass number is 12, 12 minus 6, 12 minus 6 is 6. 12 is the mass number, and the atomic number is 6, right? But I'm going to put Z because atomic number is known usually as Z. And I'm actually going to put mass number as A because usually mass number is denoted as A. And we have here carbon with a mass number 14. It's important to understand that sometimes an element can have different neutrons, making them nearly identical chemical properties. This is called an isotope. So an isotope is when we have the same element but different number of neutrons. So we're going to be able to tell that change because of a different number in mass. In this case, the mass number is 14, and then we subtract it to the atomic number, which is 8. And, I'm sorry, which is actually 6, and we get 8. So this means that we have 8 neutrons here. Next, we have electrons. Electrons are negatively charged particles, which means their charged particles are less than 0. They are much lighter than protons and neutrons. Electrons orbit the nucleus in regions called electron shells or energy levels. So this area right here, that circle part around the nucleus, those are the electron shells. That's where you can see the electrons. They're outside the nucleus. They're in orbital or energy levels. It's important to understand that electrons determine reactivity and bonding. In a neutral atom, electrons is equal to the number of protons. However, if electrons are lost or gained, that forms ions. So note that ions is when electrons are lost or gained. So let's go ahead and give an example of that. Since hydrogen has one proton and one electron, how do we know this? Because of the atomic number. According to atomic number, carbon has 6 protons and 6 electrons. Why again? Because the atomic number is 6. And how about oxygen? Oxygen has 8 protons and 8 electrons, and that is because of the atomic number once again.